Welcome to this topic video on server APIs. So, what are APIs? Well, it stands for Application Programming Interface. Web APIs are how clients talk to servers and how servers talk to each other. Okay, so how should our front-end graphical user interface in the browser talk to our server? Okay, that's the kind of thing for me here. There's probably roughly 3 popular API types right now. Remote procedure calls, which actually is a very general label. You could put all these other things could be actually classified under RPC. They're both more specific than that. REST for representational state transfer, which is the most unenlightening name for something. GraphQL, the graph query language. Okay, so we'll talk about these a little bit. Some very good readings. Check out Understanding RPC REST and GraphQL, Picking the Right API Paradigm, and GraphQL from GraphQL.org. Find out more about those things. Okay, RPC. RPC, meaning Remote Procedure Call, is the earliest and simplest form of API interaction. It's all about executing a block of code on another server, on another computer. That's all it's about. That's all it means. You're making a procedure, function call, whatever, on another machine. Okay? An API is built by defining public methods. Then the methods are called with arguments. Okay, so a remote procedure call interface is just a bunch of functions that we can call. Okay. Now, this is what I mean. All client-server interactions do look like remote procedure calls. Okay. Additional quote standards or methodologies or architecture can specify these interactions more formally. Watch out for the buzzwords. Okay, people are going to come out here with a lot of jargon. Okay, if they really understand it, they can speak about it without using all the jargon. If somebody keeps going REST, or GraphQL, blah, 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 without explaining to you why they're using that, what it does for them over other methods, then they don't know what they're talking about. This is an area just fraught with people yelling about things they don't know anything about, or that are questionable to be just yelling about. Okay. Standards and implementations, okay, can be very lightweight, suitable for like IoT, or extremely elaborate, suitable for server-to-server interactions between very different types of servers, so they have to guarantee interoperability through the standards. Okay, you can safely consider all our server interfaces so far in class as RPC APIs because everything looks like RPC. Now, getting more specific, what are some well-known RPC implementations? For a nice lightweight system, I like JSON RPC. Okay, and you can see it at the Wikipedia on JSON RPC and JSON RPC too. Lightweight, easy to understand. SOAP, Simple Object or Something Protocol. Okay, it's a messaging protocol for exchanging structured information and the implementation of web services and computer networks. This is very heavy. Okay, designed for multiple different transports, including HTTP. Hard to know what its status is. Okay, maybe more legacy systems you'll find out there with it. I am not an expert on its uptake. I do not use it. gRPC is open source from Google. It's a high performance RPC framework. Think more like binary and stuff like that. Okay, so those are implementing a classic RPC. Okay, what's an example? I know this looks a little trivial, but this is the format you would have for calling a subtraction function. Okay, everything gets put into a JSON object. Okay, we've got a part here to identify the protocol we're using. We have a part here to talk about the method or function we want to call on the server. We have another section which talks about the parameters that we're going to feed that method on the server. And finally, so we can tell multiple requests apart, we have an ID for this particular request. Okay? When the result comes back, we'll get something like, it'll remind us of the protocol, it'll tell us the results of this operation, and it'll have the ID that matches the ID in the request. Okay? Very well thought through, but still simple. Okay? It's if you have less than they're using in here, you're probably missing something that you will need if your system grows at all. Okay? So protocol versioning, request and response correlation via the ID field, and I didn't cover it here, but they have a consistent and simple error handling approach. Okay? If you're trying to get lighter weight than this, you're probably missing things that you're going to need in the future. Okay? That's why it's good to look at these things. Okay? If you need more, that's good. But if you think you can get away with less in a protocol, you should study some protocols yourself. Okay. REST. Okay. Representational State Transfer. It's based on Roy Fielding's PhD thesis. This is not a specification. So you see people arguing sometimes whether an interface is REST enough. It works very well with HTTP. And it's not just 1.1, but all the HTTPs. Why? Because Roy Fielding was a co-author of some of the early specs on HTTP. However, it's not the same as HTTP. This one we're going to cover in detail because it's a nice way to organize your APIs for a lot of purposes. Okay, it's got some issues when it comes to scaling in certain places, so it's not the end-all of end-alls. Okay, that's really why GraphQL came up. GraphQL is a query language for an API and a server runtime. Okay, for executing queries. Okay. It isn't tied to a specific database or storage engine. Okay? It provides a better way of making more efficient requests where you have a lot of potential data that you have to gather from different places. This was particularly came up where folks had some trouble getting REST to scale. Okay? So, GraphQL history, it originated with Facebook to solve performance problems they encountered trying to apply REST to all their finding out data for all their users based on their friends' data and blah, 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 blah. However, it's got staying power. Okay, it was open source and turned over to the Linux Foundation as a project. So this is not tied to Facebook anymore. They still use it though. So what is this mysterious REST stuff? Okay. This REST API tutorial will be our main reference, as it is fairly complete. It's shorter than an entire book on RESTful APIs, of which there are a bunch, and it's up to date with current practices, i.e., they use JSON for data transfer rather than XML. Okay. Within that, you'll find a resource naming guide and a summary about HTTP methods and REST. HTTP methods. To see a more detailed discussion at a higher level and such like that with history, check out the Wikipedia article. It's pretty good. Okay, so what is it? My very high level and low level views. Okay. Somebody else out there may be way more opinionated. To me, it's an architectural approach to designing client-server interfaces. What are you talking about? Remember we have to, if we're writing the server, we have to figure out the paths the server is going to respond to, right? We have functions in our server code that care about whether it's a post and what path, the path portion of the URL, we're going to do something with. So we care about methods and paths, okay? Now, REST makes strong use of existing web infrastructure, okay? They are going to use the URLs to identify application resources, okay? And that particularly means the path part of the URL, okay? We're going to use HTTP methods, okay, to identify operations that we're going to perform on those resources. Gee, this makes a lot of sense. Yeah, why have put, post, and delete, okay, if you're never going to put or post anything to a site, okay? We're going to use those methods for those types of operations. And we'll get into how REST says you should use one put for one reason and post for another, okay? They deal with content negotiation via the content type and accept headers. Oh, okay, instead of adding an extra field somewhere, we already have these in the headers, okay? In addition, we're going to use HTTP response codes as much as possible to indicate success or failure, and sometimes even the reason why for success or failure. Okay, so that's going to be what we're going to use REST to help us do. Design our paths that we're going to listen to on our servers and the methods we're going to use for those paths. Okay. Okay, now begin with some high-level principles. Don't tell you it's client-server. Yeah, Professor. Browsers are clients. Web things are servers. HTTP is a client-server protocol. You taught us that. Yeah. Okay. So yeah, guiding principles. Client-server. Yeah, we know this. This is based on HTTP. It's not the same as HTTP. You could pull this out from HTTP, but it's really a web thing. Stateless. Didn't we go over stateless a lot for HTTP? Yes, each request from client to server must contain all the information necessary to understand the request and cannot take advantage of any stored context on the server. Okay, so if we take this too literally, we're going to have to throw out everything we do later, okay? Because we're going to use cookies and session state to keep track of whether somebody's logged in or not. So for the most part, we're going to completely abide by this. But we are going to keep session state via cookies so we don't make people log in for every single transaction or present a password, okay? That's okay for machine to machine interfaces, okay? So if you take this too literally, you'd have to throw out most websites out there, okay? Uniform interface, okay? We're going to try and identify resources in a reasonable, uniform way. We're going to try and do this nicely, okay? Other principles, cacheable, a little beyond our discussion here. Layered systems. All our stuff is kind of layered, okay? It's a common architectural technique. Code on demand, we're not going to be covering that now, okay? Resource. The key concept in REST is that of a resource, okay? Resource can be a single item or a collection of items, okay? Resources can contain sub-collections of resources, okay? We are going to map resources to server URLs, in particular paths, okay? There are naming conventions to do this, okay? We're going to use the patterns and convention from REST Resource Naming Guide, okay? You'll see it's not going to be too bad, okay? You follow the rules. Okay, REST URIs should reserve to a resource that is a thing instead of referring to an action, a verb, okay? So here's example.com user management users. Okay, so this is like a collection of users. To talk about a specific user, I would somehow give them an ID, this kind of pseudo code representation, okay, of that URL. Okay, that sounds fine. Okay, resource types of things. A document, a single thing. We'll use a single noun for it. A collection, like a list of all our users. We'll use a plural noun for it. Okay. Other types of things, like a store, client managed resource repository. Okay. Like a shopping cart. Okay. These are common paradigms. Okay. They have common naming conventions. Okay. So, once upon a time, I was thinking about a multi-user system for allowing students to peer review each other's assignments. Okay? So think about that. Think of all the things we could have. We could have users. Okay? So we'd have this plural noun for a collection of users, and then we'd have a particular user ID, identifier. Okay? But wait, Professor, you give out a lot of different homeworks. Yes, I do. So we could have assignments, okay, and an ID for a particular assignment. Homework 17,032. Yes, it seems like I give that many, okay. Now, what about teacher wants to look at all the assignment submissions? Here's we have assignment, assignment ID, submissions. These URLs are starting to look complicated. Okay, these REST things. I mean, this is fine, these naming conventions, they make sense to me. But aren't these going to be a pain on the server? Wait a second. We went over this in Express. Express has root parameters. It's all set up to do things like users, user ID. Here's the user's books. Here's the book ID. Oh, it's got stuff just specifically designed to extract that kind of stuff out for us into a nice JavaScript object. Whoa, can't get nicer than that. So hence, good web frameworks like Express provide enough capabilities to help us, not do it for us, but help us easily work with REST type APIs. Okay, even if they get kind of long, that's okay. Now there's some naming recommendations. Use forward slashes to indicate a hierarchy of relationships, right? Just like we're used to in directories, right? Okay. Try not to use trailing slashes in URLs. Okay. Use hyphens, not underscores, to improve readability of the URIs. Okay. That's perfectly allowed. Don't use underscores. Sometimes underscores disappear from reading and people think they're spaces. Lowercase letters in URIs, because actually URLs, like in your up here, they're case insensitive for the most part. Okay? Don't use file extensions. We're never going to use file extensions here. Okay? Now, what can we do with resources? We can map operations with resources, like we want to do something with a user, okay, which we specify via URLs, to HTTP methods, okay? So, standard things you'd like to do, and this is how database people think: create, read, update, and delete operations, okay? For those kind of operations, remember, early web is just combining a template engine, right, with a web server, with a database, okay? There's standard ways of doing this, okay? What are they? Get. Oh, get is like the read of CRUD, okay. Use get requests to receive resource information only. Don't use it to modify resources. Makes sense to me, okay? So, response code, okay, when the resource is found. not found 404. Somehow your requests, what you're asking for is badly formed. You get a bad request. Easy peasy. Okay. Little subtlety here. Use the post method to create a new resource in a collection. Okay. Not put, but post. Okay. This is a convention. If you don't use that convention, nobody's going to come out and get you. It just might confuse people. Okay. In this class, that's the convention we're going to use. Okay. If successful, return the response code created. Okay. So that's a successful response code, but it tells more information than a 200. Okay. Okay. Now, what if we're updating an existing resource? We're going to use put. So it's create, post, read, get, update, put. Okay, to update existing resources. And finally, use the delete method for deleting resources. I know that seems a little simplistic, but we're going to apply this to our project websites, okay, and our project servers that are talking back and forth with their front ends. Okay, so we're going to use the REST paradigm for that. Be aware there are other paradigms, general and specific RPC approaches, and to go beyond REST for situations with data that access and stuff that call for it, consider GraphQL.